Hi, welcome to my video on solving related rate word problems number 2. In this video I will do some more problems. Number 1, find the rate of change in the area of a trapezoid if the base 1 changes 4 centimeters an hour, base 2 changes at 10 millimeters an hour, and the height stays constant of 6 centimeters. So we have a given. So let's see what we're given. We're given a trapezoid, and I'll just do abbreviation on that. And we have base 1, so let's call it the rate of change is dB1 dt is 4 centimeters an hour. And we have base 2, dB2, whose rate of change is 10 millimeters an hour, and we have the height is 6 centimeters, and let's see, that's all given. So what do we have to find? So we're trying to find, and this, I use the same plan every time I write down the givens, write down what I want to find the rate of change in the area. So that's dA dt, the rate of change area of a trapezoid. So a trapezoid is a quadrilateral which has 4 sides. It has a height which is perpendicular distance between the bases. This is base 1, base 2, and this is the height. So we're trying to find a change in the area. So the area is a half the height times base 1 plus base 2. That's the formula for the area of a trapezoid. So what we do, we want to find dA dt. So we have dA dt. So we do ddt on the A. So dA dt. And we do dt. So what I'm going to do is call this F and let this part be the G, so FG. So the derivative of F, a half H is, derivative of a half H is a half, and H is, that's dH dt, times B1 plus B2, that's the G, plus half H, and now we're going to do the derivative of B1, so the derivative of B1 is 1, dB over dt, and the derivative of B2, derivative of B2 is 1, so it's dB2 over dt. So that's the derivative done. So I want to find what we have here. So now what we have is dH dt, but we don't have it. But what we have is, it says that the height is constant. So that means dH dt, if the height is constant, then there's 0 rate of change. So that means that a half dH dt is 0, so the height never changed, stayed constant. The derivative of a constant is 0. So that's B1 plus B2. And I don't have B1 or B2. Let's continue. Let's see. But I also noticed, before I notice that this is 4 centimeters. This is 6. Oh my God. Just make this centimeters here now. Make sure. Centimeter. But this dB2 dt is in millimeters, so I should have all the units the same. So 10 millimeters is 1 centimeter. So all my units should be the same. So we have half H, and H is, the height H is 6, and dB1 is 4, and dB2 over dt is 1. So what do we have? That's 2 times 0 is 0, so 0 times B1, B2 is 0. this is a 5, so this is a half of 6, which is 3 times the 5. We do the brackets first. So that's 0 plus 15, so that's 15. And again, this is area. So we have a height, which is in centimeters, and we have, this is the rate, which is in centimeters per hour. So when we multiply that out, we get square centimeters per hour. So that's the rate of change based on those conditions. Again, I wanted to enter one where the variable didn't change, so we do the derivative of that variable that don't change, rate don't change, the derivative is 0. Now let's do another one on a right cylinder. A right cylinder has its radius increasing by 1 foot per second, has its height increasing by 10 feet per second, and it has the height of 9 feet. Find the surface area rate of change when the circumference is 12 pi feet. And again, let's look at what the given is. So what are we given? We have a right, and I'm just going to write the abbreviation, right cylinder, and we have the radius increasing at 1 foot, so that's dr dt is 1 foot per second. The height is increasing at 10, so that's dh dt is 10 feet per second. And we have a height of 9 feet, so that's 9 feet. And we're also given, we got to find the surface area, but we're also given that the circumference is 12 pi feet. So we have to find, it's asking us to find the surface area. So the surface area rate of change, so that's D, I'm going to call surface area SA, dSA over dt. So that's the surface area changing in time. That's the rate of change. That's what we have to find. And we have a right cylinder. So a right cylinder is, let's draw, there we go. So this is the right cylinder. It's a right cylinder. We have a height, and we have, it says that we have a height, and the radius is right here. So we want to find the surface area. So because we have a right cylinder, then the surface area is made up of the base area. So the base area is one circle here and a circle here. So that's the area of a circle is pi r squared, but the bottom is a circle and the top is a circle. So there's two circles. And we have the lateral area. So the lateral area is the circumference. So if you think about it, it's the circumference right here going around. So if you do this, and that's the circumference going around and its height. So there's the circumference times its height. So the circumference is 2 pi r times, so it's a rectangle, so it's length times width. So the circumference, again, is 2 pi r and times the height, so that's the length times the width. So that's the formula for the surface area of a cylinder. So we want to find dDA of dt. So we'll do ddt on this side, so we get the surface area dSA over dt. So we do this ddt on this term here. So that's a constant, so that's 2 pi. So the derivative of r squared is 2r, and it's dr dt. Now, what we're going to do is do this one, but again, I'm going to label this one as f and label this one as h. So that's the derivative for product rule. So the derivative of f is 2 pi is constant, so it's 2 pi. Derivative of r is 1, so it's dr dt times h. So that's derivative of f times h plus 2 pi r is f times the derivative of g. Derivative of g is 1, and it's dh dt. So we tidy all that up, and we get 4 pi r dr dt, and we have 2 pi h dr dt, and right here we have 2 pi r dh dt. So let's fill in the information. So what happens? We have 4 pi and the radius, but we're given the radius, but not directly. The circumference is 12 pi feet, so circumference is 2 pi r. So that means that 2 pi r is equal to 12 pi feet. The pi is divided by 2 pi, so r is equal to 6 feet. So we have a radius. So I gave you the circumference that you had to determine the radius. So the radius is 6, and the rate of change of the radius is 1, and we have a 2 pi, and the height is 9. The rate of change of the radius again is 1, and we have 2 pi again, and we have a radius of 6, and the height is changing. The height is changing at 10 feet per second. So we combine all those terms. We have to do all the multiplication first. So that's 24 pi. That's 2 nines 18 pi. And that's 12 times 10 is 120 pi. And all of these are areas now, because this is 6 centimeters and this is 1 centimeter per second. So all of these are all in feet per second. And we add all them up and we get 100, that's 32, so it's 162 pi. And remember the area, look where I got feet per second, that's linear. So square feet per second. Area, square feet per second. Because it's the surface area. Again, you have to, what I do is write down the givens, and if all the givens are not in front of us, then we have to work out the other unknown to complete the problem. And we write down what we're trying to find and draw a diagram, write down the formula, do the derivative of the formula, fill in everything we know, and everything works out okay. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.